Now, recording is in progress. Good evening, y'all. This is Platoon. Evenings and weekends. We're on week 10, day 3, last day of SQL before you got to be tested on it. So it's kind of a victory lap. Not doing anything crazy today. We're basically reviewing, talking about a schema, and flexing the skills we already have. I think if anything that we're adding, this maybe, I call them join tables. People like to call them many relationships, but I use join tables where I'm just, all this table does is exists to connect this thing to this thing, share their IDs, um, much like this one. Um, so let's talk about it. Um, today's lesson, we'll use grocery store DB. Let's make sure Docker, it sure looks like it's running. Pretty sure it's running. That's it. I think we're up. Let's find out. Great. Docker's up. Nothing alive on it. Today's lesson is going to use the grocery store database. I've got that repo here. We will clone it down. And just run setup. See what happens. We should create a image called grocery underscore DB. We're then going to run this Postgres database. Sorry, let me back up. We're going to run grocery DB. Database's name is going to be database. Oh God. Oh God. Lose my mind here. We're doing a few things. Let's see where we're actually at. Okay, so this execs directly in, which is cool. We're there now. We built grocery DB, running what's here. We're making some assumptions with this init.sql that will get auto-populated just due to the way that Postgres and init.SQL is being utilized. If you look at the Postgres image, init.SQL will be run if you put it here upon building, which sure looks like that's what happened. So our setup, created the image, stood it up, ran what it needed to do, hopped us in. We are immediately in the database of this container. We don't have to exec and then find our way in. We're just directly there. And this is all the stuff from our table here. Today, we're going to design the database schema for grocery store entities. We'll start with the following. We've got a customer. Store basic info about a customer. A discount. This is going to be used for, not unlike y'all's last assessment. Remember, we had different types of customers. You had the PX and SX. I don't remember what that stood for, but one's a special customer and one's not. Customer profile will store supplemental info about a customer, especially a reference to the membership type. We've got these discount types and we've got customers. To marry the two together, we're going to have a customer profile, which takes user data and store data and slaps them together. Beyond that, we have items and customer order. Our relationships here, as we kind of talked about, a customer is going to have a custom profile and a customer profile is going to belong to a customer. That's easy peasy. Oh, Jordan, we don't need it that big. All customers are going to have this customer profile. Membership ID is going to be directly pointed to the discount one to many. There are going to be one kind of discount, right? You're going to have like your veterans discount, right? But that's just one discount. but many different customers could have that. That's the one-to-many relationship there. And an item could belong to many customer orders, and a customer order can have many items, many to many. We call that out. Honestly, this is a thing I always kind of struggle with. We talk about these different types of relationships. They're good for understanding, I guess, at a level when you're explaining your database. But we don't really think about it like that often. Many to many is not a concern I'm kind of thinking about when I'm writing out these queries. Um, don't worry if you have a hard time keeping them in your head or why many to many is different than a one to many. Fundamentally, it's very similar. But these order items could have multiple item IDs for one order ID. That's that. Let's pull the queries. Talking about schemas is not as quick of a way to learn it as just pulling queries on it. Since we can't directly express many-to-many relationships in SQL, we'll have to create another table to connect them with customer order, which we did. So all we did was add order items, and that's it right here. So to implement this, customer is its own unique thing, looks good, name, email, straightforward. Table discount is we got an integer, we got a bar chart, looks good, same deal, not dependent on anything. What is this? Art, explain this. Create table method. I guess method's not the word. What's going on here?
The customer ID is acting like a foreign key to refer it back to the customer table.
Yes. Well, yes. You're absolutely right. So we're taking customer ID and we're taking membership ID. They are references to something that already, to these other tables. But what does this mean? What, like, for these here, I could create a customer and I could say, oh, name is Jordan, email is jordan@jordan.com. Doesn't matter. Uh, there's no rules. Well, okay, it's got to be 100 characters, 255 characters. This one can't be null. But for these references, what is this going to have to be? This customer ID. What is that number going to need to be?
It's gonna have to be something unique. So any orders are tied back to that particular unique ID for the customer.
Disagree. This one has to be unique. What about this one?
That one is just going to be tied to that customer ID. It's not, that's well, the value is just going to be, it has to be the exact same one as the customer ID when it's being placed into the table.
Right.
So,
So what I was pulling teeth at and probably not doing a very good job of setting it all up. This just has to exist, right? We have to have a customer. This has to be a
correct.
valid customer ID. We can't make this up. This is something that already exists. So if I ran all these create tables and then I tried to create a customer profile, I would not be able to do that, right? I would need a customer and I would need a discount because I need a valid customer ID and member type ID, right? I think we all know that. I'm just making sure we say that because sometimes people run into issues when they're building a script out where they don't quite do it in the order in which they need to exist. Item, it can be whatever it wants. Customer order, this one does reference customer ID, and then table, again, is going to be a join table of these two. So customer order is going to have a date created at time of, but it is going to be immediately referencing a customer ID right there. So pretty much anything that is emboldened is dependent upon the things it's referencing, right? If I were to create this, if I were to script this out, I need to make sure I had customers and discounts and items built. Then if I wanted to build out customer profiles, I could. And customer orders, I could do that as well once the customers are built. And then order items, I would be dependent on both of these. So then our queries should be pretty easy once everything's connected. I like this one long line, no stuff crisscrossing, reaching out different tables. You can do that to make this stuff more simple if you really wanted. I don't see a straightforward way to do that. Does anyone see any other way you might want to connect this table? I see one. What would be the benefit in connecting these two tables? Discount an item. Has anyone been to a grocery store in this class?
Yeah, so for the discount, well, you got the item there. You should have a regular price and a discounted price that's tied to the membership discount or the membership type somehow.
I agree. We could do something of that sort. If we ever wanted, right, because a member's going to have, their discount evidently, but if your items are ever being discounted for some kind of thing like that, it might make sense to connect item and discount because you could have a set discount in the database set for the item, things like that. Again, very easy to query this way around. The only benefit to connecting these, again, we don't have to. I could attach an item and discount if I really wanted to go a long way kind of through this. It's just a design choice, but I want you all to think about how you would design, a database. If you were constantly updating items with discounts and changing things, you got your rollback Mondays or whatever the hell, it might be a lot easier to make those changes if discount and item are directly related rather than have to correlate item through an order. If that customer happens to be a customer once they ordered it, let's check the profile. By the way, does their membership ID add another percent? Let's take that percent and bring it back around. It might get a little hefty. So you can add complexity to your database if it makes sense. It's more lightweight to do this until you have to start doing queries. So what is Dalton's membership type? I don't know who the hell Dalton is, but I'm guessing name, varchar. We're going to start there. How would you go about figuring out what a customer's discount type is? Nicole.
To figure out the discount type.
Yeah.
So like the percent
Or
just the membership ID or the membership type.
Yeah, membership type.
So you would have to go from customer to customer profile to discount. So it would be a
Keep going.
Select all I would select all from or star from customer and then join customer profile on customer ID and customer profile customer ID. And then again join discount on membership type to discount ID. Membership type
I,
ID, discount ID.
I agree with most of that. Oh, and this did want the percent as well. But you said select all, which we can, and that's a good start. But ultimately, when we're asking for like a specific thing, that's what our select is always going to be. What do we want to see in the end? So membership type, I guess that doesn't match the query it's asking for, but we'll get the percent as well. And as you said, we're going to start here. The customer C, we're going to join that to the profile, join them where the IDs match. And then we need to, sorry, not join. Yeah, join them where the IDs match. And then we're going to grab the discounts where that membership type equals the discount type. Does that make sense to me? No. Yeah, on customer profile. I've said it before, I'll say it again. This shorthand stuff drives me insane. I don't think it helps. But if y'all like it, feel free to use it. All right. Customer C. We're going to join customer profile on customer. Their IDs match. That makes sense. Now we're going to tack on that discount onto the customer profile where the IDs match. And ultimately, where the name is Dalton. Silver 20. Is that right? Is that correct? How could we quickly find out if that's accurate? Luckily, we've got the grocery store DB here. We can look at the init.sql. We can find Dalton, right? And this isn't something you're going to do in the real world, but we've got the init here, and I want to be able to prove our work and make sure this makes sense to us. We found Dalton. Dalton's a real person, not like that other lecture I did where the name was misspelled. So there's the customer. His ID is 10. A customer profile, well, ID, customer ID, we need to find the one that's 10. Looky there. So this is going to be Dalton right here when we do this insert. And membership type is the other one. So let's find membership type 2. What is that? Is it here? Oh, it's got to be up higher, right? Oh, no, goodness gracious, it's going to be in discount. There it is. Type 2, silver. Right. Everyone follow that. There's Dalton. His ID is 10. Customer profile with an ID of 10 has membership ID of 2. Or sorry, a discount ID of 2. Discount ID of 2 is silver. Oh, and the percent is 20. Well, follow that. We're good. We agree. SQL query didn't just spit out some numbers and we're going to say it's right. That looks good to me. It's important that we can walk through this init.sql, not to give too much away, but assessment 3, you're just giving me an init.sql and you're running a bunch of stuff. And I'm going to see if it runs through. I'm going to check it. So let's get used to looking at those. One more quick query, nothing crazy here, but there's a tricky bit that we're going to find out and we have to figure out. Adam, what is the distribution of membership types among customers? How would we fit? What is that question asking?
I have no idea.
All right, let's read it again. What is the distribution of membership types among customers? So a membership type right here. What is the distribution? So a customer profile is going to have a discount. It has to, right? You agree with that? Because it's a foreign key to a discount. And a customer profile is going to have, a customer associated with it. That's good too. But how do I figure out how many customers have, well, let's look at these membership types. We don't have to remember squat. There's bronze, there's silver, and there's gold. So this question is asking, get all the customers, figure out how many of them have gold, how many have silver, and how many have, what was it, bronze? Did I remember that right? Yeah. Does that make sense? All right. So ultimately, the table where you're going to want to see is going to be gold in a number, silver in a number, and bronze in a number, right? Because that'll be the total number of memberships that have been given out. Let's see if this makes sense. Count is going to be what we want, right? Because for all the numbers that we're able to get for every customer, we're going to be able to associate some kind of discount with them. And we're going to want a count of all of those. But we're going to be wanting the membership type to show as well, right? So from customer, we'll start there. Join customer profile. That makes sense to me. We've got the customer. We need that customer profile. On ID, nothing new there. Then we're going to left join discount D. Discount. I'm going to go back and remove. Some people love this. I'm not big enough on SQL to like these aliases. Some people say they're amazing. God, I hate reading it that way. Take our customer, join this table together, ID to ID. Customer profile, join a discount, ID to ID. Left join, I don't know, let's see what happens with that in a second. Again, ID on ID, group by membership type. We should get something like that. Let's see if we do.
Well, I know join, but what does left join do?
That's a great question that you're going to answer. All right. Well, this looks good. Gold, bronze, silver, huh? The hell's that? 23 what?
23 nulls.
Yeah, you're absolutely right. So we look at init.sql. And we go to our customer profiles. Ooh, membership type ID. No, I don't have to count them. Actually, I mean, I can count them pretty quick. Does that count? Oh, that's not going to do it, Jordan. Okay, sorry, I got ahead of myself. I bet you there's 23 of these. I bet you if we add up all of these numbers, subtract 23 from it, there'll be 27, 23. I bet there's 50 customers in total. Does that make sense? 91, 42. Yep. What's this left join? What if it was an inner join? Why did it do that? Any guesses?
Are you asking why like it removed the nulls?
Yeah.
Um, I did a little Google search on left join, so my guess is that it's only going to find the matching record. So if there's no matching records, then it's just going to eliminate it.
That's what inner join will do. So we said line them up, join them. You're going to join them where these IDs match these IDs. Wherever your discount ID matches your customer profile membership ID type. That's what our normal like inner join is going to do, right? But we said left join. So what that's going to do is take the tables we have on the left to this point are going to be customer and customer profile and match them where IDs match. But what about it doesn't matter. Throw everything over there. Throw everything from discount onto the table to the left of it. And not just the ones that match. There were none that matched here. That's why that's empty, right? Because some of these customer profiles don't have membership type IDs. It said, fine, just put a blank there and count all those as well. If we're looking to find stuff that doesn't match up to what we're trying to join, and we still want to keep track of that, doing a left join is one way to accomplish that. We can do a right join if we want to go the other way, but we're building. This is to the left. This is to the right. It's better when this is all on one line, right? But we can agree that this join happens, and if we continue going to the right, we'll have a new table, so we join to the left. Make some sense? Maybe? Am I losing y'all?
Nope, got it.
I didn't understand left join and right join at all when I went through this program. So don't feel too confused if it doesn't make sense, but it's because it wasn't really described to me in a way that I could digest. We read left or right. We want to go to the table to the left, so the left. Match, line it up. Even if stuff doesn't line up, still slap it on there. Seem good? Are we getting somewhat comfortable with looking at schemas? I don't expect everyone to be able to quickly read this, quickly digest it, quickly have a immediate understanding of what's going on here. But I would like you to be able to look at this for about 2 minutes, 3 minutes, and then talk to me about how this works. Are we around at that level? We'll see.
I think for me, it's the querying that's more difficult. I think this is something I can think through and look at it for a little bit and get it. I couldn't be able to find it if I queried it.
That is okay. This is more important to me. But obviously we're gonna need to be able to do this stuff. Art.
I just had a comment. I was looking at a video on the database design, and one thing that was really helpful that worked with my brain is that he would go from the actual design page and toggle over to the actual CSV file. And so you could see on like column 1, that was the one that was the customer primary key. So every line, every row was different. And then you would see the next line would be like the name or something like that. But that just a comment saying that was really helpful to me to see the actual CSV file compared to the actual diagram.
If that's helpful, then that's good. I don't know if that would help me or bother me looking at it that way. With these queries, whatever we're asking for, things I want to see, that's easy. Grab it. From then on out, oops, we need to figure out what all we need. Because we want Dalton's membership type. We don't need to start over here. None of this stuff's important, but we do start a customer. So that's where we're going to start. We could start a discount if we wanted and go backwards, but let's go left or right, I guess. You know, customer is going to be the first thing we're grabbing. So from customer, we need to join. That's easy, customer profile. So join customer profile. The on is important because it doesn't always know. But for stuff like this, that should be pretty straightforward. Join these. What do you join on? Well, this one's ID, customer's ID, and customer profiles, customer ID, because they're going to be the same. Continuing on to discount. Wherever these wherever these lines are, that's what we're joining on to get to the next one. That's easy peasy to kind of work out in your head. I want ultimately this stuff over here. So I'm going to select the percent and membership type from customer, join this line to this line, join on customer ID to customer profile, customer ID. Need to join again, join on customer profile discount by where they're lined up. Customer profile, membership type ID, and discount ID. Group by membership ID. We got to make sure we do that. Yes, Art.
I think what's difficult for me, I like the diagrams, but what's difficult is I'm trying to prioritize things. Okay, customer and then customer ID to that table, that sounds perfectly logical. But let's say I messed up. Can we scroll up to the diagram a little bit?
Yeah.
So let's say like just instead of customer order being below customer, let's say I screw things up and I put item, customer, and then item, and then I just swap places. So now customer order is at the end of the line. That's not something that's fatal, right? Because I can just link, join them all across and get to the information I need. It's just not as efficient as creating the diagram properly. Is that correct?
If it works, I don't know how you would get customer order out from in between customer and order items in this case, because it has to connect to these two things. Customer order, I mean, it could be over here, but item and customer don't really have anything to be joined on. How would we join customer and item?
Well, in this one, it makes more sense. But like we had some like random well, I think like kind of like the Instagram with like the post and the comments. What do I put the comments before the post table, or the table for the comments table? And my brain wasn't actually saying, well, this is a priority over this. I'm thinking that as long as I link the primary keys, I can get to whatever data I want. But it might be the long way around. Whereas if I order them properly, like in this diagram, it's just so much more efficient. It's not a fatal error. It's just more efficient to do it properly.
To a point, right? One thing I want to point out is, well, if we're talking about like, kind of supposition, it's difficult without like narrowing it down. But in your example, talk about post before comments, that's just answering questions about what is the app going to do, right? Because if we're talking Instagram, I'm making some assumptions. I don't have Instagram, but a post has to exist before a comment, right? A comment just can't exist before there's a post because there has to be an attachment. So you would never be able to go customer straight to the comment. There's got to be a post because somebody has to originate that post. And then comments have to have to come from that post. And there will be a customer associated with it. So if this was customer and this was post and this was comment, I could link these. I don't have to, but I should, because that comment probably has to have a user associated with it. Another thing to point out that I just want to be clear, I don't think this is a good thing to talk about, but I do want it to be known just for this is an exercise of our minds. If I trusted myself real good, if I trusted myself real good, could I'm putting in all the data, and I'm a perfect human. I'm going to put all the data in exactly right, and I'm going to do it perfectly every time. Do I need a foreign key here? Could I just do this? What breaks when I do that?
Or the associations with the customer.
Well,
That's one thing.
Well, so I create the customer, right? I give it the name Jordan, I give it the name, the email, whatever, and then and I get an ID, and I see, hey, Jordan's got ID 1. So when I go to create a customer profile, I say, oh, this is Jordan's customer profile. So I'm gonna put in 1, and then let me put this one in and put in 2.
Yeah, but so if you do a on cascade, or whenever that customer goes to, if there's any changes that's being made to the customer, having to manually, having to I don't even think you can, I don't know how you can even manually go back into a customer profile once it's been set to make those changes and to delete and purge all uh all of the information across the whole database.
I agree 100%. That's why these exist. But I could, right?
Yeah, you could.
That's really what I'm trying to get across a little bit is we have some level of control right now. We're building stuff from the ground up. We have some level of control of what's going in, what's coming out. And by the way, we're not going to be doing this stuff when we get to Django. This is going to be handled by Python. So we're going to have a little bit of flexibility on our tables. If it doesn't make sense to me to join a table to another table, I don't have to join it. I'll probably regret it in the future, just like Cisco pointed out. How do I know when I want to destroy some things that I kill everything that's associated with it? Well, SQL doesn't know. The more I take on, the more I'm responsible for, right? We're just using SQL to help us, not shoot ourselves in the foot. That's what these foreign keys are for. They are saying, yeah, a customer should always have a customer profile. That's why these are linked. I could also have some code written that just does that and always, fixes it for me. I can write my queries in a way that they don't even have to be connected over here, because on creation of customer profile, it also creates an item at the same time, and they're always lined up and they're never going to get out of order. It's bad design, but I want y'all to kind of play with stuff, I guess. That's all I want. I just want my students to play with things and see. I'm not going to get on this soapbox for long, but by God, a lot of the times I get questions from y'all of like, what would happen if I did this? What would happen if I didn't, follow it? It's like, man, break it. This is the perfect time to break it. I can help you fix it. A lot of these questions sometimes are really good questions. And the way I learn, and not everyone learns the way I learn, that's something I've learned when I've started teaching. But knowing what doesn't work is a good way for me to shore in what does work. I don't know if that makes sense, but like if you always do something exactly the right way every time and it always works, how are you going to know what it looks like when someone does it wrong? Right? If you only ever do things the right way, how are you gonna recognize a bug? We're working on Django and your fellow student is like, oh my God, what's this? And you say, I don't know. I always do it right. That happens all the time. And honestly, I say that a lot to students sometimes, not exactly, but I'm like, why don't you just do it the way I showed you? But I would love for you guys to try to break the stuff that we're teaching you. Um, there are no dumb questions with things like this. And I'm seeing as the internet gets better at answering our questions, uh, we don't poke and prod as much as we used to. Um, not to get on the old man soapbox, but that's the old man soapbox. That's it. Unrelated to any of this. Any last questions before we wrap up this lecture?
On the assessment, will we be getting the values?
The values.
Yeah,
What
we're
do you,
creating
what
the
do you,
database. Yeah, we're creating the database and tables, but are we gonna have to input our own values in there?
let me end this lecture real quick.
Oh, yeah, right, right.